Yes, I am. Okay. I know all my students well. Yes, I do. Yes, I do. I tell you, give me a break. You know I know you. Uh-huh.
Well, you've had her in a class for 3 years. 2, because last year she abandoned us.
I did not abandon y'all.
Yeah, you did.
I was teaching a totally different subject in grade level. I didn't abandon you. You had coach last year. How's that abandoning y'all?
Because we're used to you.
Yeah, then you got used to him. That's how it works. Yes. Okay, let's go here because Joseph is like, what did I miss? All right, 9.3 functions. A relation. Joseph does need to get better. A relation in which no two. See, look, there's not even a space there. In which no. In which no. Two ordered pairs. Remember, ordered pairs look like X and Y. Have the same first coordinate. Okay. I'll let y'all write that down. Okay. Functions. Functions are a relation. Remember, a relation is just a set of ordered pairs. Okay, we did that yesterday. A relation in which no two ordered pairs have the same first coordinate. First coordinate is X. So what this is saying is a function cannot have the same X. A function cannot have a bunch of ordered pairs that have the same X. They do not have the same X coordinate. It'd be like saying Atalia and Kelly do not have the same X. Get it? Get it?
Oh.
Because if y'all had the same X, you would not be a function. But if you both had totally different X's, then you would be a function. See, there you go, Tanner.
I don't think we learned this.
Bring it to me. So,
Maybe girl could break it.
a relation. What? A what?
It's the last one I have to do as well.
Okay, I'll call it good.
Okay, thank you.
Just because of all the fractions.
I said
You're good now.
I said
All right.
girl could break it.
That's right. It is. It is. So again, if now you find something to do.
I'm thinking.
Okay. If you can study other IXLs that I didn't assign, like similar stuff, you can just do it just to practice, okay? Not assign. So Kelly and Atalia, again, if you had the same X, you would not be a function. If you had different X's, you would be a function. Yeah. For example, let's say F equals, funky bracket, -3, -2.
I swear that you're just making a squiggly line.
3, 1, -3, 3, 4, 4, 3, squiggly. Okay. That's a squiggly. So right, all that is a, what is that called? What is this called?
Forget. Relations.
Yeah, this is a, that's right.
I wasn't sure.
No, you're correct. Good. This is a relation. This is a set of ordered pairs. All of them are just X, Y, X, Y, X, Y. So it is a relation. So I'm going to ask, is this a relation? And Natalia says yes, because everything is just X and Y.
Now I'm thinking like science, like chromosomes.
Yeah, I can see that. Okay, so is this a relation was based on what y'all learned yesterday? And yes, it is, Natalia said, because it's a set of perfect ordered pairs, X's and Y's. Is this a function?
Yes.
Why?
Because all of their X's are different.
You're correct. Yes, because no repeating X's. I'll put an exclamation mark, even though that's not capital. Okay, so I'm going to let you catch up. So is this a function? Yes, it is, because there's no repeating X's. We have a -3, a -2, a 1, a 3, and a 4. Do you see that, Kelly? Do you see each X? None of them are the same. None of them are the same. Therefore, it is a function. Now, you only, when dealing with a function, we're only talking about the X. Only talking about the X. You can have repeating Y's. You can have repeating Y's. All right. Any questions on that? No? Okay, so truly, functions, y'all have relations down. Function can't have repeating X's, and so therefore this is good. All right, I was, in my notes it shows how to write the domains and the ranges, but we did that yesterday, so I'm not going to repeat that. Let's do another one. Example. Here's my set. Now, Kelly, I'm going to ask you, when you have this written down, we're going to look at it, and then I'm going to ask you the same questions I asked Ataya, or the same questions Ataya answered. So write that down, and then when you have it down, you're going to answer this question. Is this a relation? Huh? Is it a relation? Relation is what we did yesterday. Why is it not a relation?
Because there's 2 3's.
Okay, but we're talking about relation, not function. So relation means that they're all ordered pairs.
Oh, yes.
So yes, it is. Because they're all ordered pairs. They're all perfect. There's not just one number. There's not 3 in here. You know what I'm saying? They're all perfect X's and Y's, right? Now, is this a function, Kelly?
Yes.
It is
Well,
a function? Why is it not?
because it has to repeat.
That's right. These x's, and that's the only thing you look at. Yes, there's a 5 with the y, a repeating 5, a repeating y, but that doesn't matter. You can have repeating y's, but you cannot have repeating x's. And here we have two x's that are exactly the same. So it is no has repeating x. So it has a repeating x. So it is not a function. And I can even say 3. The 3 is repeating. Any question? Okay. Moving right along. When we're talking about functions, it's going to, come on, Kelly, you don't need to make all that noise. Sometimes it's going to say f of x. Sometimes it's going to say g of x. But that is how a function looks. The f and the g mean nothing. They're just calling it that. F of x, that's how I'm going to say it, or g of x. Sometimes they'll even say, they'll have an h there or an m. Most of the time it's an f, and then sometimes they'll have a g. But it means, the f and the g or the h or something means, it's just the name. But this and this really mean y. But since we're talking about functions, okay, you know how we have y equals 2x, and that's your equation? You know what I'm talking about? Well, now they're going to replace that y with like f of x or something like that. It just means the y. But because we're dealing with functions, they change it up a little bit. Yes?
So
And I'll give you examples.
What if is it f, or do they just put f?
They have it looking just like this, f of x or g of x. And a lot of kids are like, I don't understand what that means. It really doesn't mean a lot. And I'm going to give you a good example. Okay, hold on. Tanner, can you go to Spanish and tell Taylor Miss Williams needs him? And she's with wherever Miss Burke would be. Thank you. Okay. All right. So, for example, let's say you're given f of x equals 2x plus 4. Okay, you're given 2x plus 4. F of x equals 2x plus 4. That's basically saying y equals 2x plus 4. It's kind of the same thing. When you're looking for y, using random x numbers. F of x is really your y in disguise. Miss Burton needs you.
Oh,
I mean, not Miss Burton. Miss Williams needs you.
is it in Miss Burke's room?
It's
Because the computer lab's empty.
it's empty. Then go to Miss Burke's room. Okay. So write that down, and then we'll move on. As soon as I start giving you examples, you'll figure it out. Y'all got it? Okay. So, for example, let's go back to this one right here. F of x equals 2x plus 4. Okay. Choose any random x. Atalia, choose any number for x.
7.
Okay, good. So we're going to replace this x with 7 because Atalia chose it. 2 times 7 plus 4. So therefore, f of x is what, Atalia? What is 2 times 7 plus 4? 18. Therefore, remember I said this is like your y, right? So your ordered pair, Atalia chose 7 for the x, and we replaced that x that's in the equation with her 7 because that's what she chose, and we got y as 18. There's her answer. That's it. That's not bad, is it?
How are you supposed to grade them then if you pick a random number?
Trust me. Trust me.
But if you pick a random number.
Sometimes. Okay. So in this case, sometimes they're going to ask you, they're going to say, all right, here's your equation. They're maybe going to tell you to graph it. They may tell you to graph it. So here's your equation. You get to choose random x's, put them in there. You got an ordered pair, you can now graph it. See what I'm saying? If you have several of these, if you do, like if you choose 5 or 6 different x's, you have 5 or 6 different ordered pairs, and then you can graph it. And no matter what numbers you choose for x, this is like a thumbprint. The graph will all look the same. Like if Atalia chose -3, -2, 0, 1, 2, and 3. Let's say she chose all of those for her x. And then you chose totally different x's. Y'all's graph would be identical. Because this is like a thumbprint, and no matter what x you choose, when you graph it, they will all look the same. It's quite interesting.
I'm so confused. Meaning if we graph it.
If you, no matter what x, like if Atalia, no matter what x's Atalia chooses, she works it out and she gets a bunch of ordered pairs, right? She goes and she graphs it. And then you choose totally different x's that she didn't, okay? Totally different ones. You solve it, get your ordered pairs for the same equation. Your graphs will be identical.
How?
That's the way it works.
And then we get what our dots be on different places?
No. It just will work out. It will just work out. The graph will, yeah, your dots will be in different places. However, it will still fall on the same lines, just different places. It's kind of crazy. But we'll do some examples later. All right, a graph may be used to determine if a relation, remember a relation is your ordered pairs, is a function. So earlier, y'all looked at a bunch of ordered pairs, and you both were able to tell if it was a function or not because it didn't have repeating x's, right? Whether it has repeating x's. But now we're going to look at a graph to determine this. It's called vertical line test. And I will tell you, in all the years of teaching algebra, my students love this. It is not a function if two or more points lie on the same vertical line. No same x. Once you get that, I will draw some examples. Okay. Here are some examples. This is my Cartesian plane. Thank you. Okay, there's my Cartesian plane. He cannot figure it out. All right, y'all have this? Okay, that doesn't have to be perfect. It doesn't have to be perfect. Okay, so just wait and look. It doesn't have to be perfect. But a vertical line test means that it says a function it's not a function if two or more points lie on the same vertical line. So basically, if I were to take my pen, draw a line like this, any of those vertical lines that I just drew, do they go through more than one point at the same time? Look right here. That's right. See how it went through 2 points in the same vertical line? Up and down. Therefore, it is not a function. Not a function. These are okay because the vertical line that I drew only goes through one point. But this one right here goes through two. And if you look, this point is -3 and 2. This one is -3 and -2. Remember the rule for functions? Look at that. Has the same x. Therefore, it is not a function. I'm going to show you another one. This will be even better. Okay, so there's my graph. There's my Cartesian plane. What if I draw my graph do the vertical line test?
Is that where the dots are supposed to be?
Look, does it cross my graph in two places? Look right here. I could do it right here too. Look. Look at that. Yes? Yes. That's the vertical line test. If you can draw a vertical line and it crosses the graph or points, if it crosses the graph in more than one place or 2 points, it is not a function. Y'all see that? Kelly, do you see that? And once you have that down, I'm going to draw another one. You got it, Kelly? All right. Whoops. You ready? Here's my graph. Let's do the vertical line test. Does it cross my vertical lines? Do they cross the actual graph? Not the Cartesian plane, but the graph. Does it cross in more than one place? I'm looking at this right here. No. Oh, here's one, here's one, here's one, here's one, but it doesn't cross in 2 places, right? So is this a function? Yes, is a function. Is a function. So that's the difference. Do you understand? Okay. So any graph, you just draw vertical lines, and if it only crosses in one place, then it is a function. If it crosses in 2 places, then it is not a function. Y'all see that? All right. Open up your books. Oh my word. Love third grade. Page 360. All right. I tell you, open your book. What? What?
On the actual Cartesian plane. So it doesn't matter if the vertical lines cross the actual.
The Cartesian plane?
It doesn't matter.
Correct. It does not matter.
Okay.
Yeah, that's a good question. It's only the graph, not the Cartesian plane. Okay. Number 2. Let's get going. Determine from the sets of ordered pairs whether the relations are functions. Kelly, look at the set of ordered pairs on number 2. Is it a function?
It is not a function.
Why?
Because the x's are not the same.
That means it is a function. Yes is your answer. Because there are no repeating or same x. Do you see? Be careful with that. Italia, number 4.
No, because the 3's repeating.
That's right. It's no because the 3's are repeating. Okay? Do you understand? I'm going to put that repeating just for your notes. Hey, 6th grade, no talking. All right, 6. Kelly?
It is a function. Wait, no. It is not a function because there are repeating negative ones.
That's right. Very good. Because they're repeating negative ones. Good job.
I just realized, how would Joseph know? Because he wouldn't,
What?
like, if he didn't have, or like, if he didn't have his book.
Well, they're picking his book up today. All right, 8. Determine from the circle mappings whether the relations are functions. We're going to skip the circles. There's no reason to go into that.
I didn't even know we're not going to.
Yeah. Let's look at 14. Look at 14. Determine from the graphs whether the relations are functions. Atalia? They are. Yes, it is. Very good. Because there's no repeating x's there. You can draw that vertical line and will not cross any of those dots more than once. Kelly, look at 16.
No, it's not a function.
Very good, because there are 2 dots there that you could cross with a vertical line. Very good. Atalia, 18.
It is not a function.
See, isn't that nice? You can start seeing it now. Good job. All right, let's look at 20. All right, here's where it gets kind of crazy. Okay, so it says in the directions, they give you the equation f of x equals negative 3x plus 2. And they want you to find the following. So for number 20, they said, they said f of negative 2. So what did they replace with that negative 2? They replaced the x. So then we're going to replace that x right there with negative 2. So I have negative 3 times negative 2 plus 2. So Italia, what is negative 3 times negative 2 plus 2? There's your answer. Any questions about that? Seriously. That's kind of easy, right?
I was confused for a second, but I got it.
They see, here's the equation they give you in the directions. For number 20, it says f of negative 2. So they replace that x with negative 2. So you're going to replace that x with negative 2. I'll even draw a little arrow.
The reason why I was confused because it was negative 3 times negative 2, and it was positive 6.
Oh, okay.
last two. So I was like, is this supposed to be negative?
Well, then you understand. So 19 through 30, it's all you're just replacing the x with what they give you. So let's look. I think I'm going to just call it good. Y'all ready to do some work? All right. Thank you for helping her. No, let's do 38. 38 says find the range of the following functions if their domain is. So they give you a domain. What's domain again?
The x's?
That's right, the x's. So these are your x's. So for 38, they have this equation. G of x equals negative x minus 1. So all we're going to do is I'm going to make a table.
Oh, this is what we did this time.
Yep. And I'm going to take this, put it here. Negative x minus 1. And it's going to give me my y, my range. So we're going to put all of these x's here, negative 3, 2, and 5. And look, this is a negative x. So watch how I write this.
Wait, so wouldn't the top one be positive?
That's right. That's right. That's right. So write this down, and then Natalia, you tell me what the first y would be. Because, look here, Kelly, negative and negative gives you a, so then positive 3, right? And then so Natalia, what is the y for this?
Negative 10. Because negative.
What negative and negative gives you a positive.
So 3 times.
Minus.
Oh, we're not doing this.
Look, right, this is your equation.
Oh.
See, we substituted. So negative.
So it's 2.
That's right. So your ordered pair is
I was looking at the negative 3.
negative 3 and 2.
I was multiplying positive 3 by negative 3 and then subtracting.
Oh my
negative.
goodness.
That was right.
Kelly, what would the y for this one be?
Negative 3.
So then my ordered pair is 2 and negative 3. And Natalia, what would this one be?
Negative 6.
And there's my answer. Any questions? This is not too bad, right? So you're going to do page 360. I won't give y'all too much.
The full page.
No. So some of these you're just looking at, right? And I'm going to skip those circle things. So numbers 1 through 5, odd. That's 3 problems. Then 13 through 17, odd. That's another 3. Then 19 to 23, odd. I'll avoid the little fraction there.
That's another 3.
And then 37 to 41, odd. That's another 3, isn't it?
Yeah.
3, 6, 9, 12. Due Thursday. Okay, get started.